the 2,000-year-old computer that shouldn't exist. Imagine diving into the dark blue sea. You are searching through the remains of an ancient shipwreck. You find statues. You find coins. You find ancient objects covered in sea life. And then you see something strange, a small, heavily damaged piece of bronze. At first, it looks like nothing special. But hidden inside this mysterious object are dozens of tiny gears. And those gears are more than 2,000 years old. How could ancient people build something that looks like a mechanical computer? This is the incredible story of the Antikythera Mechanism, a discovery under the sea. The story begins in 1900. Greek sponge divers were working near the island of Antikythera between the Greek mainland and Crete. They discovered an ancient shipwreck lying deep beneath the Mediterranean Sea. The wreck contained many incredible objects. There were statues, coins, jewelry, glass objects, and other ancient treasures. But among these discoveries was something very different. A collection of corroded bronze fragments. Nobody immediately understood what the object was. It looked like a strange piece of metal. But scientists eventually discovered something extraordinary. Inside the bronze were tiny gears, not one or two gears, many gears working together. The discovery changed our understanding of ancient technology, a machine from the ancient world. The object became known as the Antikythera Mechanism. It was probably created more than 2,000 years ago during the ancient Greek world. Researchers believe it was a hand-powered astronomical calculator. It could model cycles involving the sun and moon and could help predict eclipses. It used mechanical gears to represent complicated astronomical patterns. Think about that for a moment. Today, we use computers and smartphones to calculate astronomical events. But more than 2,000 years ago, someone created a mechanical device that could perform sophisticated astronomical calculations. There was no electricity, no computer chip, no modern factory, only bronze, mathematics, craftsmanship, and an extraordinary understanding of astronomy. How did it work? The Antikythera Mechanism was made from bronze gears and contained inscriptions written in ancient Greek. When a person turned a handle, the gears moved. Different gears represented different astronomical cycles. The device could track the movements of the sun and moon and could predict lunar and solar eclipses. It also contained calendar information. Researchers have found evidence that it was connected to major cycles used by ancient Greek astronomers. The machine was essentially turning mathematics into movement. Instead of using a modern screen, the ancient user could look at dials and pointers. The gears did the calculations. The incredible moon. One of the most impressive parts of the mechanism concerns the moon. The moon does not move across the sky at exactly the same apparent speed throughout its cycle. Ancient Greek astronomers carefully studied these movements. The Antikythera Mechanism used a sophisticated arrangement of gears to reproduce the changing motion of the moon. This was not simple clockwork. It required mathematical knowledge and extremely careful engineering. Recent research continues to examine exactly how the ancient designers created these calculations mechanically, the times of India. Why is it so mysterious? Here is the strange part. The Antikythera Mechanism is unique. Nothing else from the ancient world with exactly this level of mechanical complexity has survived. Researchers know that ancient Greeks understood mathematics and astronomy. They know that Greek scientists developed sophisticated theories about the movements of celestial bodies. But the mechanism shows that some of this knowledge was transformed into an incredibly complex physical machine. And then, this tradition seems to disappear from the archaeological record. For more than 1,000 years, we do not see another surviving device with comparable complexity. That is one reason the Antikythera Mechanism is so important. Nature. The lost technology. Imagine being an ancient engineer who knows how to build this machine. You have learned how to calculate astronomical cycles. You know how to cut bronze gears. You know how to make tiny teeth fit together. You understand mathematics. You build the machine. Then you teach another person. That person teaches another. But what happens if the knowledge is lost? What happens if the workshop disappears? Who built it? This is another mystery. We do not know exactly. Part 2. The secret inside the 2,000-year-old computer. What could a machine built more than 2,000 years ago actually do? When scientists first examined the mysterious bronze fragments from the Antikythera shipwreck, they could hardly believe what they were seeing. Inside the corroded metal were tiny gears. These gears were not random. They were part of an incredibly sophisticated machine. But what was it designed to do? A computer without electricity. The Antikythera Mechanism was not a computer like the machines we use today. There was no electricity, no battery, no screen, no software. Instead, the machine used carefully designed bronze gears. A person turned a handle and the gears moved together. Each gear represented a different mathematical or astronomical cycle. The machine transformed numbers and mathematical ideas into physical movement. It was almost like having an ancient mechanical calculator. Watching the sky with gears. The ancient Greeks carefully studied the sky. They watched the sun. They watched the moon. They observed the planets and stars. They noticed that many astronomical events followed patterns. The Antikythera Mechanism was designed to represent some of these cycles. It could show information about the movement of the sun and moon and could help predict eclipses. For people living more than 2,000 years ago, this was extraordinary technology. Imagine turning a handle and watching a pointer move across a dial to represent an event in the sky. Predicting eclipses. One of the most impressive functions was connected to eclipses. A solar eclipse happens when the moon passes between the Earth and the sun. A lunar eclipse happens when the Earth comes between the sun and the moon. Today, computers can calculate eclipses almost instantly. But the ancient designers of the Antikythera Mechanism understood that eclipses followed predictable cycles. The machine used gears to represent these patterns. It did not see the future. It calculated cycles using mathematics. That difference is important. The machine was not magic, it was engineering. The mysterious moon. The moon created an even greater challenge. The moon does not appear to move at exactly the same speed across the sky throughout its cycle. Ancient Greek astronomers knew about this changing motion. The Antikythera Mechanism included a sophisticated system of gears designed to reproduce the moon's changing apparent motion. This required advanced mathematical thinking. It also required incredible precision from the person who made the gears. Think about making tiny metal gears without modern machines. Every tooth had to work correctly. If one part was wrong, the entire system could fail. More than an astronomical machine. The mechanism was not only about the stars. Its surviving inscriptions and dials indicate that it was connected to calendars and astronomical cycles. It appears to have been a compact educational and calculating device. Perhaps an educated person could use it to understand the relationship between different cycles of time. The machine may have been used by astronomers, teachers, or wealthy individuals interested in science. We cannot know exactly who used it, but we know that someone had enough knowledge and skill to create it. The lost knowledge. And now we reach the biggest mystery. If ancient engineers could build something this sophisticated, why don't we have many other examples? Perhaps machines like this were rare. Perhaps they were produced in specialized workshops. Perhaps other machines existed but were destroyed. Bronze could be melted down and reused. Wooden parts could decay. Machines could be damaged during wars. And written instructions could disappear. The Antikythera Mechanism may therefore be only one surviving example of a much larger technological tradition. Modern technology solves an ancient mystery. The original mechanism is heavily damaged. For many years, scientists could only study its visible fragments. Then modern technology changed everything. Researchers used advanced X-ray imaging and other scanning techniques to examine details hidden inside the bronze. They discovered inscriptions and mechanical structures that could not be seen from the outside. Piece by piece, scientists began reconstructing the machine. It is an amazing partnership between ancient and modern technology. Ancient engineers created the mystery. Modern scientists are trying to solve it. What we still don't know. Even after more than a century of research, important questions remain. Who exactly built the machine? Where was it made? How many similar machines existed? Who used it? And how did ancient craftsmen develop such sophisticated mechanical knowledge? Scientists have proposed different answers, but some parts of the story remain uncertain. And that uncertainty makes the Antikythera mechanism even more fascinating. Part 2.